Good morning, students. In last class we learned from atomic structure. In last class we learned what are the different characteristics of waves. Wave nature, light, nature of the light, in that particle nature and also wave nature. So light has two natures, dual nature of light, that is the particle nature and also wave nature. Nothing but light in the form of particle propagate in the form of a wave. So that is emitted in the form of particle and that propagate in the form of wave, that contains both particle nature and also wave nature. So what are the characteristics of waves here? Wavelength, frequency, wave number, velocity and amplitude. What are the definitions and units we learned? Anyhow, once again, what is that wavelength? Wavelength. Characteristics of waves. So wavelength represented by lambda. What is this wavelength? So here wave, light propagate in the form of wave. This is called crest and this is a trough. This combined is a one wave. Okay, like this, crest and trough. The distance between two successive crests, this distance is the wavelength, or the distance between two successive troughs, this length is also called wavelength. So what is wavelength? The distance between two successive crests or two successive trough, that distance is the wavelength. What are the units of this wavelength? Wavelength units are angstrom. 1 angstrom is equal to 0.1 nanometer, units are nanometer, or picometer, 100 picometers. 1 angstrom is equal to 100 picometers, or it is a centimeter meter. Okay, it is equal to 10 power minus 8 centimeter and 10 power minus 10 meters. So this conversion important for to solve the problems. So what are the units of wavelength? Angstrom, nanometer, picometer, meter, centimeter. 1 angstrom is equal to 0.1 nanometer, nothing but 10 power minus 1 nanometer, 100 picometers. Okay, so it is a angstrom wavelength, the distance between two successive crests or two successive troughs, generally represented in angstroms only. This is wavelength. And next one is the frequency. What is this frequency? Represented by nu. Okay, frequency represented by nu. What is this frequency? The number of waves crossed a point, just one point in this path of the wave light, the path of light, just put one point. Okay, light propagating, now you put one point, then how many waves crossed this point in 1 second time? The number of waves. Anyhow, this is propagate in the form of wave. Just 1 second time only we should observe that. Just in 1 second time, just one point is used in the path of that wave. So how many waves crossed? Because this is the one wave. So how many cycles crossed or how many waves crossed a particular point in 1 second time? So in 1 second time, how many waves crossed? That is called a frequency. Okay, that is the frequency, the number of waves crossed a point in unit time. Unit time means 1 second time. So what are the units? Hertz or cycle per second, or simply second inverse. Hertz or cycle per second or second inverse. Okay, this is frequency. And next one is wave number. What is this wave number? Wave number represented by nu bar. Wave number represented by nu bar. So what is this wave number? Just we have to take one unit length. Unit length, for example, this is only unit length. Okay, unit length. The number of waves present in that unit length. How many waves are present in that unit length? That is called wave number. So in this distance, this is unit length. How many waves are present? Here how many waves are present? 2 waves are present. Nothing but the wave number is 2. So the number of waves present in unit length, that number is wave number. The number of waves crossed a point in unit time, 1 second time, that number is frequency. That is frequency. And distance between two successive crests or two successive troughs, that distance is a wavelength. Okay, that distance is wavelength. This is a wave number. And velocity. What is this velocity? Distance travelled by this wave in 1 second time. The distance travelled, that is the velocity. It is represented by c. So velocity of light is 3 into 10 power 8 meter. per second or 3 into 10 power 10 centimeter per second. Okay, the distance travelled in 1 second time by wave, that is the velocity. And next one is the amplitude. What is this amplitude? This is represented by A. Okay, this is independent. These four are related with each other. What is the relation later? Now, amplitude. What is this amplitude? The height of the crust. How much height is there? Or depth of the trough. How much depth is there? The height of the crust or depth of the trough. That is called amplitude. So, if wave strength is more, height of the crust is more, depth of the trough is also more. So, what is the importance of this one? Amplitude value is more, its strength is also more. That wave strength is more. These are characteristics of waves. Wavelength, frequency, wave number, velocity and amplitude. Wavelength means the distance between two successive crests or two successive troughs in wave. That distance is the wavelength. Units of this wavelength: angstrom, nanometer, picometer, meter, centimeter. And frequency. What is this frequency? The number of waves crossed a particular point in unit time, 1 second time. That number is a frequency. It is represented by nu, and units of this frequency: hertz or cycle per second or second inverse. Okay. Next, wave number. What is this wave number? The number of waves present in unit distance. This is reciprocal of this wavelength. Reciprocal of wavelength means what are the units? Centimeter inverse. Because wavelength unit centimeter or meter. Now, what are the units of this one? Centimeter inverse or meter inverse. Meter inverse. So, this wave number is the reciprocal of that wavelength. So, number of waves present in a unit length, that is the wave number. And velocity, the distance travelled in 1 second time. So, meter per second or centimeter per second. The value of light, this velocity of light is fixed value, that is the 3 into 10 power 8 meter per second or 3 into 10 power 10 centimeter per second. Okay. Next, amplitude. What is this amplitude? The height of the crust or depth of the trough. That is the amplitude. Okay. Now, what is the relation between these four? Lambda, nu bar and C. So, just a problem, sir. One they will give, another we have to calculate. To calculate this, what is the relation? Frequency, how many crossed? It depends on velocity and distance between the waves also. How many crossed? If distance is more, less cross. If distance is less, more waves will cross. That's why it is directly to this, proportional to this C and inversely proportional to this lambda. Nothing but nu is equal to C by lambda. So, what is the relation between these three? Nu is equal to C by lambda. The speed, velocity is more waves cross. But this distance between two crusts more, less waves will cross. That's why it is directly proportional to C, inversely proportional to lambda. Nothing but nu is equal. What is the relation? Nu is equal to C by lambda. So, wavelength increases, frequency decreases. As the wavelength increases, frequency decreases. Now, two wavelengths given. Lambda 1 given, lambda 2 given, nu 1 given. Calculate nu 2. What is the relation? Lambda 1 given, lambda 2 given, nu 1 given, nu 2 they are asking. It is inverse. So, nu 1 by nu 2 is equal to lambda 1 by lambda 2, lambda 2 by lambda 1, lambda 2 by lambda 1. They will give any three values, another one we should calculate. So, what is the relation? Nu 1 by nu 2 is equal to lambda 2 by lambda 1. The relation is nu is equal to C by lambda. And anyhow, nu bar is equal to 1 by lambda. Nu bar is equal to 1 by lambda. Instead of this 1 by lambda, substitute that nu bar. Now, nu is equal to C nu bar. Nu is equal to C nu bar. Then, nu 1 by nu 2 is equal to nu 1 by nu 2. It is directly proportional to this nu bar, directly proportional. This is inversely proportional to lambda because this is only constant. C is a constant. So, proportionality removed, this constant we are using. Nu is equal to C by lambda. Now, it is directly proportional to this nu bar. The constant is C. So, nu is equal to C nu bar. Nu 1 by nu 2 is equal to nu bar 1 by nu bar 2, nu bar 2 by nu bar 1. Directly proportional, nothing but it is a nu bar 1 by nu bar 2. So, what is the relation? Nu 1 by nu 2 is equal to nu bar 1 by nu bar 2, nothing but any two wave numbers they will give, and one frequency also, another frequency we should calculate. So, what is the final relation? Nu 1 by nu 2 is equal to lambda 2 by lambda 1 equal to nu bar 1 by nu bar 2. Okay. C is the velocity of light, that is the constant, its value is the 3 into 10 power 8, remaining changes, remaining how to calculate. This is the relation between characteristics of waves. So, nu is equal to C by lambda and nu bar is equal to 1 by lambda. So, from this nu 1 by nu 2 is equal to lambda 2 by lambda 1 equal to nu bar 1 by nu bar 2. Okay. For example, how they will ask problems related to this. Wavelength of light is, take pen and paper, just one problem only. So, how they will ask problems related to this. The wavelength of light is 3000 angstroms. The wavelength of light is 3000 angstroms. One light wavelength is 3000 angstroms. Calculate its frequency. The wavelength of the light is 3000 angstroms. Calculate its frequency given. So, how to solve this one? What is the relation? Nu is equal to C by lambda. Okay, nu is equal to C by lambda. Now, C value, if this one we are taking in meters, lambda also in meters. This is in centimeters, lambda also in centimeters we have to take. Now, for example, this is in centimeters. How much? 3 into 10 power 10. C value 3 into 10 power 10 centimeter per second. If it is in meters, this is constant value. This value we should remember. Velocity of light, that is the 3 into 10 power 8 meter per second or 3 into 10 power 10 centimeter per second. Okay, this is 3 into 10 power 10 by wavelength. How much given? 3000. 3000 means 3 into 10 power 3. Okay, 3 into 10 power 3. Convert into centimeters, because this in centimeters. 1 angstrom 10 power minus 8 centimeters. 3000 angstroms, 3000 into 10 power minus 8 centimeters. Yes or no? 3000 into 10 power minus 8 centimeters. Now it is equal to 3 into 10 power minus 5. Yes or no? 3 into, this is 10 power 3, it is a 10 power minus 8, nothing but it is a 10 power 3 minus 8, 10 power minus 5. So, what is this value? 3 into 10 power minus 5 centimeters. So, what is the wavelength in centimeter? C value in centimeter we are taking, that is why wavelength also in centimeter. So, what is the value? 3 into 10 power minus 5. Okay. Now, it is equal to 1 into, shift this here, 10 power 5. 10 power 10, 10 power 5, 10 power 15. So, what is the frequency answer? 1 into 10 power 15. Just like this we have to solve the problems. Okay. Now, what is the ratio of frequencies with wavelengths 4000 angstroms and 3000 angstroms? What is the ratio of frequency they are asking? Nu 1 by nu 2 they are asking. What we should do? Nu 1 by nu 2, 4 by 3, 3 by 4. Just two radiations wavelength, 4000 angstroms and 3000 angstroms, 3000 angstroms. What is the ratio of their frequencies? Ratio of their frequency they are asking. Nu 1 by nu 2 is equal to formula lambda 1 by lambda 2, lambda 2 by lambda 1, lambda 2 by lambda 1. So, nu 1 by nu 2 is equal to 3000 by 4000. So, answer is 3 by 4, not 4 by 3. Just like this problems. Just one they will give, another we have to find. Otherwise, ratio calculation. Okay. This is the relation between characteristics of waves. Wavelength, wave number, frequency, velocity and amplitude is independent. That is the amplitude, just height of the crust or depth of the trough. This is about characteristics of waves. Okay. So, now Maxwell electromagnetic waves. electromagnetic spectrum. So what is this electromagnetic spectrum? Maxwell electromagnetic waves. What are these electromagnetic waves? Any charged, electrically charged particle that is moving, any electrically charged particle is moving, it produces an electric field and also magnetic field. Maxwell electromagnetic spectrum. So first of all, what is that Maxwell electromagnetic waves? Any electrically charged particle, if it is moving under acceleration, so now here it produces electric field and also magnetic field. Electric field and also magnetic field. If any charged particle is moving, then it produces a electric field and also magnetic field. Okay, like this electric field, and magnetic field also produces. These two are perpendicular with each other. Electric field and magnetic field are perpendicular with each other. This is if it is a electric field, then this is a magnetic field. Electrically charged particle, any particle if it is moving, then it produces electric field and also magnetic field. Now this electric field in the form of wave, magnetic field also in the form of wave. Now these two electric and magnetic fields are perpendicular with each other. These two are perpendicular with each other and both propagate with the same speed, that is equal to velocity of light. The velocity of these electromagnetic radiations, it is equal to velocity of light, nothing but electric field and also magnetic field. What is that velocity? Meter per second. 3 into 10 power 8 meter per second. So both propagate with same speed, same velocity, same frequency and same wavelength also present. So electric field, magnetic field, both are produces, both are perpendicular with each other and both propagate with same velocity, that is equal to velocity of light, and they have same wavelength and same frequency also. One electrically charged particle, if it produces, in that these two fields, wavelength is similar, frequency also similar, and these radiations can propagate even in a vacuum, not like cathode rays and anode rays. For cathode rays, anode rays, we used one medium. In the discharge tube we used gas, okay, and anode rays depends on nature of gas, cathode rays independent of nature of gas. Anyhow, for that propagation we used gas, nothing but one medium we used, but here no need to use any medium. These rays can propagate even in a vacuum. So very important point, electromagnetic radiations can propagate in vacuum. They can propagate in vacuum. They are perpendicular with each other and they propagate with same speed. That speed is, that velocity is equal to velocity of light, and they have same wavelength and frequency. Like this, different electromagnetic radiations are there. All these electromagnetic radiations are arranged in increasing order of their wavelength. Increasing order of their wavelength. So that arrangement is a electromagnetic spectrum. So first, what is that electromagnetic radiation? Different electromagnetic radiations are there. Electromagnetic radiation means any charged particle, if it is moving, that produces electrically charged particle. If it is moving, that produces electric field and magnetic field. That radiation contains electric field and magnetic field. This electric and magnetic field perpendicular with each other, propagate in the form of wave, and velocity is a constant. That velocity is equal to velocity of light, and they can propagate even in vacuum. What is the characteristics? They can propagate even in vacuum and they have same frequency and same wavelength. This is one electromagnetic radiation. Like this, different electromagnetic radiations are there. All these electromagnetic radiations are arranged in increasing order of their wavelength. This is also very important entrance point of view. All the electromagnetic radiations are arranged in increasing order of their wavelength, nothing but decreasing order of their frequency. That arrangement is a electromagnetic spectrum. Electromagnetic spectrum. Electromagnetic spectrum is arrangement of all electromagnetic radiations in increasing order of their wavelength. That arrangement is a electromagnetic spectrum. So what are these electromagnetic radiations? Cosmic rays. Cosmic rays, gamma rays, X-rays, UV rays, visible rays, IR rays, microwaves and radio waves. So these are electromagnetic radiations. So cathode rays, anode rays options given, they are not electromagnetic radiations. Cathode rays, alpha rays, like this, anode rays, canal rays given, they are not electromagnetic radiations. Which are electromagnetic radiations? Cosmic rays, gamma rays, X rays, UV rays, visible rays, IR rays, infrared, IR, UV, ultraviolet rays, and IR, infrared rays, microwaves, radio waves. These are electromagnetic radiations. All these radiations are arranged in increasing order of their wavelength. Now this arrangement only increasing order of their wavelength. Increasing order of their wavelength means decreasing order of their frequency. Decreasing order of their frequency. This arrangement is a electromagnetic spectrum. So electromagnetic spectrum means all these electromagnetic radiations are arranged in increasing order of their wavelength or decreasing order of their frequency. So what is that arrangement? Cosmic. Definitely you should remember, you should practice this. Cosmic rays, X rays, gamma rays, X rays, UV rays, visible rays, IR rays, microwaves, radio waves. Okay. So how they will ask questions? The following electromagnetic radiation with highest wavelength, options X rays, IR rays, UV rays, cosmic rays. Cosmic rays, 4 options given. Electromagnetic radiation with highest wavelength. Question is this, electromagnetic radiation with highest wavelength. In these 4 options, which one having highest wavelength? What is that order? Cosmic rays, gamma rays, X rays, UV rays, visible rays, IR rays, microwaves, radio waves. Radio waves highest, radio given, not given. Microwaves highest, micro given, not given. Then IR rays highest, IR given, given. So answer is the second option. So electromagnetic radiation with the highest wavelength. Given answer is the IR rays. Just this order we have to practice. That arrangement is the electromagnetic spectrum. So all electromagnetic radiations are arranged in increasing order of their wavelength or decreasing order of their frequency. So in these, which one has highest frequency? If the question is highest frequency, now X rays, UV rays or cosmic rays? Highest frequency, frequency decreasing order, starting highest frequency. What is the starting one? Cosmic rays. So cosmic rays highest frequency. So which one has highest frequency? Question given answer is the 4th option, cosmic rays. Okay. So like this they will ask questions related to electromagnetic spectrum. So any charged particle moving and acceleration that produces electric field and also magnetic field. What are the characteristics of these electromagnetic radiations? Here electric field and magnetic field are perpendicular with each other. This point given correct option. They are perpendicular with each other. They can propagate even in vacuum. This is also correct statement. And they propagate with the velocity of light equal to the speed of this equal to velocity of light, that is 3 into 10 power 8. This is also correct statement. And they have same wavelength and frequency. Okay. Next, all these arranged in increasing order of their wavelength. That arrangement is a electromagnetic spectrum. Okay. So now Planck's quantum theory. What is this Planck's quantum theory? In Rutherford, their spectrum, we are getting a discontinuous spectrum, not continuous spectrum. Nothing but there one drawback we learned in Rutherford's atomic model. So So if electron loses energy continuously, electron revolve around the nucleus continuously. If it loses energy continuously, that fed into the nucleus, atoms collapse. That is one drawback, but atoms are stable. Another drawback, if it loses energy continuously, we should get continuous spectrum, but we are getting discontinuous spectrum, like lines we are getting, nothing but losing energy again taking gap, losing energy again taking gap. Why like this? Okay, so in this Planck's quantum theory, that only we are going to learn the nature of the light. This is related to nature of light only. So energy, nothing but light energy. So energy emitted in the form of, so any body that not loses energy continuously. According to Planck's quantum theory, energy not emits continuously, not absorbs continuously. Energy emitted or absorbed in the form of small packets. Energy emitted or absorbed in the form of small packets. Anyone that loses energy or absorbs energy, that energy in the form of small packets, not continuous, that packet is called photon. That packet name is a photon, or it is called quanta. That's why the theory is the Planck's quantum theory. That packet is called quantum. So energy not emits or absorbs continuously. Energy emitted or absorbed in the form of small packets. That packet is called photon. If it is light energy, it is called photon. Any other given, that is called quantum. So energy emitted in the form of packet. This packet energy is directly proportional to its frequency, because that propagate in the form of wave. So its packet energy is directly proportional to frequency. So any body that emits or absorbs energy discontinuously, not continuously, emits or absorbs in the form of small packet, that packet is called light energy. For example, that packet is called photon. If it is light energy, it is called photon. Any other energy given, then it is called quantum, but energy emitted in the form of a packet only. For example, it is light energy emitted in the form of packet, but propagate in the form of wave. Light propagate in the form of wave. Nothing but this energy of this packet is directly proportional to its frequency. The energy of packet is directly proportional to frequency. This is the Planck's relation. So E proportional to nu. Remove this proportionality. E is equal to h nu. This h is a Planck's constant. This h is Planck's constant. Its value, this is Planck's constant, 6.626 into 10 power minus 34 joule second. So what are the units of Planck's constant? Given answer is a joule second. What is the value? 6.626 into 10 power. Avogadro number? Avogadro's number 6.023 into 10 power 23. Planck's constant value 6.626 into 10 power minus 34 joule second, or it is equal to C value. What is the velocity of light? Velocity of light constant, that is the 3 into 10 power 8 meter per second, or 3 into 10 power 10 centimeter per second. Avogadro number fixed. What is that value? 6.023 into 10 power 23. And h is Planck's constant. Its value is constant. What is the value of Planck's constant? 6.626 into 10 power minus 34 joule second, or 6.626 into 10 power minus 27 erg second. This is the Planck's constant value. Anyhow, what is the expression? E is equal to h nu. Okay. Instead of nu, if lambda given, wavelength given, nu is equal to c by lambda. Yes or no? So instead of nu, we have to use this c by lambda. E is equal to hc by lambda. hc by lambda. If nu bar given, wave number given, how to calculate the energy? 1 by lambda is equal to nu bar. 1 by lambda is equal to nu bar. Instead of this 1 by lambda, if substitute nu bar, now what is the formula? E is equal to hc nu bar. So wave number given, this formula we have to use. They will give wave number. We know C value constant 3 into 10 power 8. We know this H value 6.626 into 10 power minus 34. They will give wave number. Just we have to calculate the energy. So energy is equal to Hc nu bar. Okay. Otherwise energy if lambda given, Hc by lambda. Direct frequency only given, E is equal to h nu. One packet energy is like this. Avogadro number of packets given. Avogadro number of packets, 1 mole, then into Avogadro number h nu. If Avogadro number of packets, 1 mole packets given, any Avogadro number into h nu. 1 packet given is equal to h nu. Okay, 1 mole packets given, Avogadro number into h nu. Anyhow, what is the relation? E is equal to h nu. Now, E1 by E2 is equal to E1 by E2. Just mole given, like this we are using, but how many given into Avogadro number, because 1 mole contains a Avogadro number of particles. 1 mole packet, Avogadro number of packets. Okay, 1 mole given like this, but Avogadro number, how many they are asking, into Avogadro number we have to take. Then E1 by E2 is equal to, this is directly proportional to nu, nothing but nu 1 by nu 2, inversely proportional to lambda, lambda 2 by lambda 1, directly proportional to nu bar 1 by nu bar 2. Okay, here they will give these two, calculate this ratio, or they will give these two, calculate this ratio, or these two, calculate this ratio, any two relations. So what is the relation? E1 by E2 is equal to nu 1 by nu 2 is equal to lambda 2 by lambda 1 is equal to nu bar 1 by nu bar 2. Okay. So now it is the relation between energy, frequency, wavelength, wave number. This energy given by Planck's quantum theory. So light energy emitted in the form of packets, that packet is called photon. If other energy it is, that is called quanta. The quanta energy is directly proportional to frequency. So nu proportional to E proportional to nu, then E is equal to h nu. H is the Planck's constant. Planck's constant value 6.626 into 10 power minus 34 joule second, or 6.626 into 10 power minus 27 arc second. Instead of nu lambda given, substitute C by lambda. Instead of this lambda nu bar given, anyhow we know 1 by lambda is equal to nu bar. So E is equal to hc nu bar. Finally, this is the relation. Okay, E1 by E2 is equal to, what is the relation? Now one question. One theoretical question, one problem. First answer this theoretical question. Electromagnetic radiation with high energy. Electromagnetic radiation with high energy. First option, visible. Second one, UV. Third one, IR. Fourth one, X-rays. Electromagnetic radiation with the highest energy. Options given. Which is the correct option? Highest energy. All these radiations are arranged in increasing order of their wavelength or decreasing order of their frequency. That arrangement is called electromagnetic spectrum. Anyhow, we learned that electromagnetic spectrum. What is that order? We know. Order we know. Now 4 options given. Energy, highest energy they are asking. So what is the answer? Highest energy. Visible or UV? Highest energy. So here wavelength increases. First in rough paper we have to write that order. What is that order? Cosmic rays, gamma rays, X-rays, UV rays, visible rays, IR rays, microwaves, radio waves. Okay. Here what happens? Wavelength increases. Wavelength increases. Wavelength increases means energy. Wavelength increases. In this order wavelength increases. Wavelength increases, frequency decreases. Frequency decreases means energy decreases, because E is equal to h nu. E is directly proportional to frequency. Frequency decreases, energy also decreases. Now here energy decreases. In this order energy decreases. Which one has highest energy? Cosmic rays. Option given? Not given. Gamma rays? Not given. X-rays? Given. So answer is X-rays. So, electromagnetic radiation with the highest energy, given answer X-rays. Like this they will ask questions. Highest energy or highest frequency, highest wavelength. Anyhow, this arrangement is a electromagnetic spectrum. Now, this energy relation given by Plancks. So, it is a Plancks quantum theory. Now, problem how they will ask. Wavelength of photon emitted. The wavelength of photon emitted is the energy emitted in the form of packets. That packet is called photon. So, the wavelength of the photon emitted is 6000 angstroms. The wavelength of photon emitted is 6000 angstroms. Calculate the energy of that photon. Fast. Calculate. The wavelength of the photon emitted is 6000 angstroms. Calculate the energy of photon. Calculate the energy of photon. Wavelength given, energy they are asking. Wavelength given, energy. What is the relation? E is equal to hc by lambda. Because wavelength given, no. E is equal to h nu, instead of that hc by lambda. E is equal to energy, if options are in joules, definitely this one we have to take in joules. This in joules means this must be in meters, because it is in joules. So, remaining 2 in meters. What is the value of this h in joules? 6.626 into 10 power minus 34 joule second, h value. Anyhow, we learned that h value. Okay, into C in meters. In meters, what is the value? 3 into 10 power 8. 3 into 10 power 8. Now, wavelength in angstrom given. This also in meters only we have to take, because this given in meters. This is in meters. In meters, how much? 3000 means 3 into 10 power 3 into in meters 10 power minus 10. Yes or no? 10 power minus 10. Then simplify this one. 3 given or 6000 given? 6000 given. 6. We should convert into meters. Okay. Minus 7. Shift this here. Plus 7. 15. 6.626 into 10 power minus 34 into 10 power 15 into 3 by 6. 3.3 into 10 power minus 34 and plus 15. This is the minus 34 and this is the plus 15. Okay, 19. Okay, 19. 3.31 into 313 into 10 power 19. This is the answer. Finally, it is in joules. Okay. So, it is the calculation of energy. Like this problems they will ask. Theoretical questions means which one has more energy. Anyhow, it is a Planck's quantum theory. E is equal to h nu. Okay. So, this Planck's quantum theory successfully explained the nature of the black body. What is this black body? Nature of black body. What is this black body? Black body means, anyhow you know black holes. Black body means a perfect absorber and perfect emitter of all radiations. All wavelengths, total wavelength absorbs. So, the perfect black body means substance that absorbs all wavelengths and also can emit all wavelengths. Nothing but it is a perfect absorber, black color, perfect absorber and also perfect emitter. That is when summer season wearing black is not good, like that they will tell. So, it is a perfect absorber and also perfect emitter, absorbs all radiations and emits also all radiations. That is the black body. Black body means perfect absorber, perfect emitter of the all radiations. That is black body. So, here how to create this black body? For that Planck used one halo sphere. Okay, one halo sphere and one small hole. He placed one small hole here and inside complete coated with a platinum black. Inside total coated with a platinum black. He used one halo sphere and one small hole he placed here and inside total coated with a platinum black. Then this, if any light radiation is allowed to fall in this. So, here it absorbs total radiations and also emits the total radiations. Now, absorbs all and emits all. So, wavelength and intensity if graph given, If it absorbs or emits radiation continuously, we should get the graph like this, continuous absorption emission. Okay. So, like this we should get, but we are getting graph like this. Okay, like this we are getting graph. This is at a temperature T2 for example, and like this at temperature T1. This is at T1. So, just here, what are the observations in this Planck's black body nature? What are the observations? Here what we can observe, black body means first of all it is a perfect absorber and also perfect emission of all radiations, that is a black body. There is no perfect black body. Nearest black body like this we can create. How to create that nearest black body? Take one halosphere and place one hole on that wall and inside complete coat with a platinum black. Then it absorbs all radiations and emits. This also acts as a nearest black body, not perfect, 100% not black body, nearest black body. Now, if it emits or absorbs energy continuously, like this we have to get the graph, but we are getting graph like this. So, what we observed here at lower wavelength, this is the wavelength. So, listen this one, this is wavelength. At lower wavelength, the intensity of light is less. At higher wavelength also, the intensity of light is less. But at moderate wavelength, the intensity is more. Intensity is more. And here, this is at temperature T1, it is a T2. For example, it is a higher temperature, it is a lower temperature. If temperature increases, the intensity, nothing but peak, shift towards the lower wavelength side. At less wavelength only, we are getting highest intensity. At less wavelength only getting highest intensity. Nothing but here energy is emitted in the form of packet. Energy emitted in the form of packet, discrete packets, not continuous. Energy is not emitted or absorbed continuously. That emission or absorption in the form of packets only. That's why we are getting graph like this. So, in this graph what observed? At lower wavelength and higher wavelength, the intensity of light radiation is less, minimum. At moderate wavelength, the intensity of radiation is the maximum, and temperature increases, the intensity, peak of the curve shift towards the lower wavelength side. Nothing but at less wavelength only, if temperature increases, the highest intensity we are getting. At less wavelength only we can get the highest intensity when if temperature increases. Anyhow, the conclusion is here energy emitted in the form of packets. That packet is called photon, or it is also called quanta. Nothing but it is a graphical representation for that explanation, nothing but black body. Anyhow, Planck explained the nature of the black body. Black body nothing but it is a perfect absorber, perfect emission of all radiations. That is the black body. How to create this black body? Just one halosphere, that is a small hole we have to place on wall and inside coated with a platinum black. It acts as the nearest black body, and this also emits or absorbs energy, but not continuously. Emission or absorption in the form of packets only. So, packet emission and then it takes a break. Okay, not emits continuously, not absorbs continuously. And here in this observation, three statements, very important one. What are the correct statements? What are the correct statements? The first one is wavelength, lower wavelength, higher wavelength given, the intensity of that radiation is less. Very less wavelength is not good, very high wavelength also not correct. And at moderate wavelength, the intensity is more. The intensity is more. And temperature increases, the peak shift to the lower wavelength side. Peak shift to the lower wavelength side. Nothing but highest intensity we are getting at a lower wavelength only if temperature increases, and energy not emits continuously. It emits in the form of packets. That is the Planck's quantum theory. So, what are the characteristics of waves? Wavelength, wave number, frequency and velocity, amplitude. What is the relation? Nu is equal to C by lambda and nu bar is equal to 1 by lambda. Okay. Then nu 1 by nu 2 is equal to lambda 2 by lambda 1 equal to nu bar 1 by nu bar 2. Based on this they will give the problems. Okay. Anyhow, it is the relation between characteristics of waves. And next one is there is a characteristics of waves. Now it is a Planck's quantum theory. Before that we learned what is that Maxwell, electromagnetic radiations, electromagnetic waves. So what is that? Any charged particle, if it is moving under acceleration, that produces electric field and also magnetic field. These two fields are perpendicular with each other and propagate with the velocity of light, and they have same wavelength and same frequency, and they can propagate even in a vacuum. Okay, so all these electromagnetic radiations are arranged in increasing order of their wavelength. That arrangement is a electromagnetic spectrum. Okay, up to that energy relation not came. Then Planck given this energy relation. So Planck's quantum theory. What is this Planck's quantum theory? Energy not emits or absorbs continuously. Energy always emission, absorption in the form of small packets only takes place. That packet is called a photon, or it is called quanta. This packet energy, it depends on frequency. Frequency increases, energy of this packet also increases. So the energy of this packet is directly proportional to nu. So E is equal to h nu. H is a Planck's constant, that is a 6.626 into 10 power minus 34 joule second, or 10 power minus 27 erg second. Okay, that is a Planck's constant. And next he explained black body nature also. So what is that black body? It is a perfect absorber and also perfect emitter, but here also energy in the form of packets only, not continuous. Okay, so this is about Planck's quantum theory. Okay, so the next one is a photoelectric effect. What is this photoelectric effect? How to calculate the kinetic energy of that electron? Okay, photoelectric effect, it is in next class. Anyhow, 5 common names now. So note down 5 common names. Common names. Plaster of Paris given, I think. Oil of vitriol. This one given. Oil of vitriol or king of chemicals. Oil of vitriol. Given, I think, first 5 common names. Okay, other one. White vitriol. ZnSO4 7H2O. ZnSO4 7H2O. Green vitriol. Oil of vitriol, king of chemicals, sulfuric acid given. Green vitriol. FeSO4 7H2O. And blue vitriol. Blue vitriol. CuSO4 5H2O. CuSO4 5H2O. Blue vitriol. Next one. Globus salt. Na2SO4 7H2O. Sorry, 10H2O. Globus salt. Na2S4 10H2O. Washing soda given? Not given, I think. Washing soda. Na2CO3 10H2O. Hydrated. Complete today common names hydrated. Globus salt Na2S4 10H2O. Washing soda Na2CO3 10H2O. Blue vitriol CuSO4 5H2O. Green vitriol FeSO4 7H2O. And white vitriol ZnSO4 7H2O. This is about 5 common names. Okay. So daily you should revise from beginning all common names, then you can remember. So continuation tomorrow. Thank you.